Hi Anatol, as I talked to you, we have a problem about how we report average phase shift for four limbs. Because as you see in this figure, the amount of phase shift the amount of phase shifts are different for legs and arms. For example, for arms we have about 3 or 4 degree um, for during perturbation, but for the legs we have about 20 degree phase difference. um, However, we suggested that there was no significant difference between phase shifts of four limbs. This result seems to be a bit confusing. The reason that we observe this difference between legs and hands is related to the Hilbert transformation algorithm and how it calculates phase shift. Um, in this figure, we try to explain you the algorithm of the algorithm of the Hilbert transformation for calculating phase shift. Firstly, the Hilbert transformation. For example, we have these two signals, the blue and the red one. The original signal and the projected one. For example, for our data. Firstly, the Hilbert transformation decomposes two signals to their frequency components. These two signals that you see contains, for example, three components here, three components with different frequencies and different amplitude. Here we have decomposition, component 1 for signal 1 and signal 2, component 2 for signal 1 and signal 2, and also component 3. If we want to calculate phase difference in a given moment, for example here that we showed with the vertical green line, we have three phase. The Hilbert transformation gives us three phase difference for this component, for this component, and for this component. So we don't have only one phase difference, but we have the average of phase difference of the components. Therefore, if both phase advance or phase delay occurred within these different components, they neutralize each other by averaging. So maybe we get, for example, we get smaller phase difference. Therefore, the possibility of neutralizing is high for a signal including more components. When a signal has more components, it is less harmonic. And when a signal contains only one frequency, it is a single harmonic periodic signal. Here, for the legs and hands, we see that in this figure. We see that the hand signal it is less harmonic. It means that it contains more components than legs signal. Legs signal seems more harmonic in comparison with the hand signal. Because of that, for when we the output of Hilbert transformation for hands and legs are different, because for example maybe hands has 4 components, so we have 5 components, so we have 5 phase difference. You see here, when we average these 5 components, we get for example 3 degree. But because legs has less component than hands, for example if we have 2 components with this amount of phase difference, the average is 20 degree. So this is why we get a different amount of phase shift for hands and legs. In your paper, it seems that in your study the phase shift calculates only for one frequency, one component, maybe the component with the least amplitude or with the least frequency. We don't know, but it is what Dr. Baghdadi understood from your study. We tried to write a code like your study, but Dr. Baghdadi told me I can't understand what exactly they did, but our data, we can not use this formula for our data. So we decided to use Hilbert transformation. But Hilbert transformation has an advantage because of the average of all signals. So your study and our study in calculating phase shifts are different, and because of the hand signal, we get different phase shift for legs and hands. So we decided to use the standardized value of legs and hands for comparison before statistical analysis. So we decided to use this formula here for standardizing the 4 limbs, and then we did a statistical analysis. For example, here we have phase shifts for right foot, left foot, and right hand and left hand, and here is the standardized values. But a question maybe arise here, because if we see in the figure, this figure, the phase shift for the hands and legs in the figure is similar. It is because of this reason that the plot is only for the components that I mentioned before. This plot just only for one component, the component with maybe the large amplitude. When we have a signal with more components, maybe we have discrepancy between what we observe in the figure and what we get from the Hilbert transformation. The more component, the more discrepancy between what we observed here. For example, here. For example, here we have two signals for right hand and right leg for one of the subjects. What we see visually here, we can see that the phase difference between legs and hands are similar, only visually. But the output for the hands is about 2 degrees, but for legs is about 60 degree for this cycle. What we see in the figure and what the Hilbert transformation calculate are not necessarily the same, because the figure represents only one component, probably the largest phase difference. So here maybe it is a bit confusing, and we don't know how to report this. When we represent this figure, the amount of phase shift between the legs and hands are the same, but in this figure they are not the same, because these figures are the average components, and these figures are the only for the one component. Lei and I decided to show here the standardized values, so we can have these two figures, and we can merge these two figures to one figure with the standardized value. But for explaining in the text, it's a bit difficult, and we tried to write more clearly, but it seems that you didn't satisfy with our explanation.